Welcome to Maths Bridge. Let's learn Java programming. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. Java operators. Operator means it performs the operations on operands. So operator and operands both are required for doing this chapter. That's the first thing. And then this is an essential but simple topic. So if you know already in some other program, that same concept works here, except that the Java syntax. Okay, let's look at like one by one. So let me take arithmetic operators for now. What is meant by arithmetic operator? It's like a binary operator. For instance, you require two operands and an operator. So what are the operators we have in arithmetic? We have like plus, minus, multiplication, division, modulus, increment and decrement. Right? This is what I think we can see mostly. So let's take a simple example like having two numbers and then doing a math arithmetic operation for all the the operators that we have. So if you look at here, I'm adding two numbers, I'm subtracting two numbers, I'm multiplying by two numbers, I'm using like a division two numbers, numerator divided by denominator. I'm also applying like a modulus to get the remainder. Is it? Similarly, I do like pre-increment and then pre-decrement. So let me I think looks like it is compiled properly. I don't see that any errors, but these small warnings that we can talk about later. So let me run this program and then see output. What are the inputs that we're given? We're given like a 200 and 100. So adding two numbers is like a 300. That's good. And subtracting 200 minus 100 is 100. Multiplication basically gives like a 200 times 100. Yes, you got it. Division means like a 200 divided by 100. So 2. Modulus no remainder. So it expected. Increment 200 and 100 can be incremented, right? Incremented by 1. So we got like a, you see here plus increment, right? This means like increment by 1, and hence I got this increments. If you can actually subtract 1, then you got like original numbers. This is how like an arithmetic operators works. Now let's see assignment operator. What is meant by assignment operator? You are assigning a value to the variable, right? So equal is assignment operator. If you look at this one, int inum 11, so inum is like an integer variable. This is called a declaration, but during the declaration you are also initializing, right? It means like the value 11 assigning to the, and the right side value assigning to the left side variable. That is how I read it. So we have the few more assignment operators wherein, so inum equal to plus equal 10. What that means, like you can rewrite as a inum equal to inum plus 10. So adding 10 and then assigning back to it. So operators. So you will look at these things are arithmetic operators, and then assignment operator is what you see by having these kind of a definitions. If you can run this program, yes, you see that output as expected. So is initially is 11, now adding 10 is a 21, right? So subtracting 10, again 11, right? Multiply it by 10, 11 times 10 is like 110, divided by 10, again back to 11, and then you see the modulus operation here, remainder, how much remainder? 11 by 10 means like, quotient is 10 but remainder is 1, so you got 1. So this is how assignment operator works. So case 3, comparison operators. Comparison operators means like the relational operators. Basically you're comparing between the two numbers, whether it is a equal, not equal, greater than or equal to, less than or equal to, that sort. And then logically you see like the result of this comparison is basically like either true or false, the boolean value, right? Based out of the value you can execute the if blocks. That is how this the sample program illustrates for us. So let me first run this program and then see like what is an output and then compare them. Okay, I got actually step 2, step 3, step 4 on console, not every statement. It makes sense, we are filtering some of them based out of the condition. What is the number that is given here is like 150. If you look at a step 2, what is a step 2? Have a number 1 is not equal to number 2. You're right. 10 is not equal to 50. So this logically this condition is true. It returns a true value. If true means like you are letting this if block gets executed based out of this condition. So that's why we got the message. Got it? Look at now step 3. What is there in step 3? Number 1 greater than number 2. Is it 100 greater than 50? Correct? No. So this logically this is true. So it returns true because this returns true. If true means like if block is going to be your execution statement, right? So this block gets executed and hence we can see this one. Similarly you can see step 4. What is there in the step 4? Greater than or equal to. This also makes sense because it's also true and hence I got this. Rest of all probably like logically returns false. If false means like else block gets executed, not the if block, and hence those are gets filtered. You see, and it basically like this works for actually filtering. You can skip certain statements to execute and then you can allow the other statements to be executed. That is how that if block works. But what we do is like we are using like a comparison operator for doing that. So next case, logical operator. So what is meant by logical operator? Logical operators are kind of like simulation of logical gates in the digital circuitry. So logical gates means like the basic building blocks of the gates are called AND gate, OR gate, NOT gate. So AND or NOT are basically is gonna take like input as a the logic input and then produce the logic output. That's an idea. So logic means like a 0 and 1. 0 and 1 in the sense like a false and true. That's an idea. Okay, 0 means false, 1 means true. So and OR actually accepts like two inputs, but the two are like a logical inputs, and hence if you look at that our programmatically left side expression should be a logical expression, right side expression should also be a logical expression. Upon evaluating this expression, what you get is like a logical result, right? Those results will be applied as an input to the AND operation. Clear? If we just to look at this one, let's say for example number 1 is a greater than 5. What is the number 1 value? Is a 10. So 10 greater than 5. Is it true or false? Absolutely true, right? So left side is true. Look at the right side now. Number 2 is a 6. 6 is less than 5. Is it right? False. So if you see like this is a true, this is a false. So what actually AND will return? So AND will return in this case is like a false, because AND always produces a logic 1 for logic 1 as a input for the both inputs. Let me reiterate. If the left side logical expression is true and the right side logical expression is true, in that case only AND returns true. Rest of all cases AND returns false. If you wanted to quickly look at this, let's run it and then see the output. Do you see now? False. The reason behind is this is true, this is false. That's why you got it. Let's see if you can change this to the other way. So number 2 is greater than 5. This case like left side expression is true, right side expression also true. True and true becomes like a true. Let's see that one also. You got the point now, right? That's excellent. This OR operation, this is called OR. OR means any one of the input, if at all any one of the inputs given to the OR gate is 1, then it produces output as a 1. Let's say for our case, right, this is a true, right, this is a false case. So since I have 1 true, then automatically my output would become like a 1. This is what it says, true. Okay, let's look at now this one. This is basically a NOT. Whatever the logical the whatever the expression it returns a logical value, you are negating that value. For instance, here num1 is greater than 100, means like a 10 greater than 100. Is it right? No, absolutely. So what it evaluates to? False. Correct? This condition is a false. Now we are applying a not to the false. Not false means what? It's a true, right? So that's why we got to see true. So this and or not operates in that case, because in the programmatically when you're writing a programs, you have to have like some conditions, right? Based out of the some criteria only, that particular block should be executed. More than one condition to evaluate these operations is going to help us. Concept is simple. Let's not get confused, but do a little more like a math work. You should be able to actually pick it up this concept easily. Now let's look at like a the bitwise operator. Bitwise operator operates on bits. So every number that you're gonna store in computer as a binary stream, right? Ones, zeros, and all. Every number you can represent as a binary stream. For example, if I have like a f, 0f is hexadecimal value, equivalent of binary is like a 4 ones. Similarly, I have hexadecimal A. This is like a decimal 10. Equivalent of binary is like 1010. The reason I'm just capturing here is like it applies on bits, not on the whole number, right? That's called bitwise operator. So the symbol that we use, like this is a bitwise AND, this is a bitwise OR. Logical AND means like a double AND, double OR, right? Something like that. So bitwise means like only one, right? Single ampersand, single OR operations. So how it works? So let's first run this program and then see the output, and then you can compare, right? So first one is I got it 10. What I get this one 10. So what is mean by AND operation? So it's a kind of AND but bitwise AND. It operates on the bits. 1 and 0. 1 means like it true. That's what we studied, right? This is true, this is 0. So AND gives always 0, because in order bitwise AND to return true, the both input should be 1, right? So if you look at like 1 0 0 1 1 1 1 0 0 1 1 1 1, so what will return is like 1 0 1 0 is going to return upon this expression evaluation done, right? So the value is like a 0 here, which is also nothing but your 10 in decimal, and hence your output is 10. Okay, the other one you see num1 or num2, this is kind of OR operation. OR means if any one of the input is 1, then output will become like a 1. How do you say this one? 1 0, we have 1, right? So if 1 0 becomes like a 1, 1 1 you are adding 1 1 is becoming 1, 1 0 become a 1, 1 1 become a 1. So that means like if you see at least a single one, automatically output becomes a 1 from the applied two inputs. So and hence our output would be like all the ones, which is nothing but f, and hence I see this value. So decimal value of f means, what is the decimal value? It's nothing but 15. Do you see? The third one is like a complement value. So 0x00f, right? This is what you can call the hexadecimal value, and then you applying to it is means like a binary value, right? If you can represent as a binary, the complement means like 1 become 0, 0 become 1. The equivalent of that value is nothing but your negative value. This is kind of a complemented, right? So are you getting? This is called bitwise operators. We have the AND, OR, and negate. Complement is what we discussed. We have exclusive OR operation and all. You can practice them. Now let's coming to the shift operator. Shift operator means you can think of like in a binary data. So let's say if I have two numbers, right? What is the equivalent of binary is like all the ones are 1 0 1 0. This is kind of like a equivalent binary representation for given decimal values. So shift operator works on the byte stream, right? Bit stream. So 1 0 0 1s and all. What it will do, like when you say like a left shift, all this actually shift by 1, move to the left by filling 0 at the right side. That is how it works. See if you can convert that value what is the equivalent of decimal value is basically multiplying given number by 2 is what we get it. Left shift means a multiplication. Indirectly is notating multiplication. How do you prove that? Yes, I have taken like a 15, right? When you left shift by 1 means like multiply by 2. So 15 times 2 is what I get here. So let's quickly look at this answer. By running this application, you see given 15 and then we got 30. If I would say like a twice, when you do like a twice, what happens, like you have to multiply 2 times, right? So 15 times 2 and times 2, how much you get? 15 times 2 is like 30, 30 times 2 is like 60, right? Let's look at like whether you're really getting. Should be, do you see 60? This is what it is. The other cases now is like right shift. Right shift means like a divided by 2. So how do you get this one now? So what is the number that is given for the number 2 is like a 10. 10 divided by 2 is like a 5. That's what exactly we got it, isn't it? So this is called a left shift and a right shift. This also assigned left signed right shift. But there's one more actually in the Java. We have three greater than symbols, which is nothing but a unsigned right shift, right? This is same as like a right shift, but only thing is like the most significant left bit always filled with a 0 if there is a vacant. So we are not considering sign bit. That's an idea. Unsigned meaning. Okay, this is again, if you look at like binary representation of any number, you will understand what is meant by signed, what is meant by unsigned, how you are actually representing that in in the digital circuit system, right? For now, this you can think of like you have a signed left shift, signed right shift, and then unsigned right shift. These three shifts are possible in Java. I think this is only you can see in Java, not in C or C++. Now we can see concept of ternary operator. Ternary means like what? It's like a conditional operators. If else, then a simulation is what it means, like a ternary operator. So if you look at like a if else statement, it is like a if block and else block, right? So rather than actually saying this all, now you are actually making like a single line statement. This is called like, if this is true, it returns A, otherwise it returns B. That sort of like a message it is. Okay, so this is called as a ternary operator. You can actually write this one like this: if A greater than B, then return like printf. Let's use printf now. Printf, what is this value? You should say A, right? Else, what do you do? Return B. So you don't see that any difference in the output if you really look at these two, right? So what I will do, like I will just compile this, and compilation already done anyway. So it's my bad, Let's run this and then see result 25, result 25. So what it means, like instead of like writing these many lines of the code, you can replace with a single line. That is what mean by ternary operator magic. You get this point? There is a pros and cons between like when to use and all, but again, debugging like a nested ternary operator is very tough than the if else block, right? But otherwise, like it is a simple to write and then a single line statements. That is how you could see. Got it? Excellent. Unary operator. This is simple thing, right? So that means like operator works with one operand. What that means is like if you take a int a is equal to 10, let's apply negative a, right? Minus a. That is what unary means, like unary minus, unary plus, and all. You can do that. Let me run this and then see what would be the output that you are getting. Yes, the input is 10. This is what is displaying. Now you applied minus to it, and hence now we got a minus 10. So this is called like an unary operator. Got it? We're all good, right? So now we covered like all 8 cases of operators. Okay, quick recap. So what we covered first case is like arithmetic operators, right? And the next case what we did is like an assignment operator. And third one what we see is like a comparison operator, right? And then fourth one what we see is like logical operators. Fifth one what we have seen is that bitwise operators. And sixth one what we have seen is like a shift operators, shift left, shift right as assigned, and then one more unsigned. Okay, with this symbol. And then seventh one what we have seen is like a ternary operator. Eighth one is unary operators. That's why we covered all the operators. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.